Good day, I'm Norman Wildberger, and today we're going to continue on with our investigation of the history of logic, going back also to ancient Greek times, just a little bit after Apollonius. A second important thread of study in ancient Greek times are the Stoics. So Stoicism is a school of Greek philosophy that was founded by Zeno of Citium, who lived from 334 to 262 BC. This is opposed to the other Zeno that's usually associated with the paradoxes. So it's a form of philosophy that's these days still well known, often associated with asceticism and sort of Spartan lifestyle. One says somebody's stoic if they can persevere through difficult times, maintaining an equal balance. But historically, the school embraced not just a way of living, but actually a way of thinking about the whole world. So there was an aspect of logic, of physics, and ethics. The logic, which we're mostly interested in, concerned with rhetoric, grammar, and the rules of thought. There was also a physical or a metaphysical aspect, understanding science or the universe. And then this ethical aspect, that the way to attain happiness was through peace of mind, basically by living in sync or in accordance with the laws of nature and striving to be virtuous. Okay, so that's the Stoic position, and we're particularly interested in their development of an alternate way of thinking about logic, quite separate and distinct from Aristotle's point of view. Now, historically, it turned out that Aristotle's thinking prevailed, and the Stoic point of view was eventually almost forgotten until relatively recently. But nowadays, I think we are starting to appreciate that they had their finger on some actually quite modern ideas. Now, Zeno's school was influenced quite a lot by another school known as the Megarians, and I'll talk briefly about them later on. But Zeno's orientation was the sort of these 4 steps of understanding or ascending to become a wise person: perception, assent, I'm not entirely sure what that means, comprehension, and then knowledge. So 4 steps towards becoming wise. But the logical doctrine that we're particularly interested in was really crystallized by Chrysippus. Okay, so this is a interesting fellow who lived from 279 to 206 BCE. So he sort of was one of the leaders of the Stoic school. And he basically founded a propositional logic. He evidently wrote huge amounts of things, and he was actually very influential and a very highly regarded logician in the Greek times. But sadly, we have very little of his actual direct correspondence and his writings. So most of what we know about his writings is fragmentary or through some indirect or secondary sources. And in fact, a lot of our knowledge of his branch of logic comes from later summaries and in fact criticisms of Stoicism. Because Stoic philosophy maintained itself throughout the Greek period into the Roman period, and then there were sort of some critics of Stoicism who refer to these earlier works, and often that's how we end up finding out about what the original proponents believed. So to understand the Stoic logic, let's compare it to Aristotle's logic. So as we saw in our last lecture, Aristotle had a logic that was concerned with statements of this relatively simple form: all A are B, all men are mortal, all Greeks are men, stuff like this. Or maybe some variants like all Greeks are not fish, or some Greeks are tall, or some Greeks are not tall. Those kinds of constructions, typically involving a subject and a predicate. The subject is like a noun, like Socrates is mortal. The subject would be Socrates. It's sort of like a noun. The mortality is like called the predicate. It's like an adjective or sometimes maybe a verb. So there's some obvious sort of connection with linguistics or grammar here. The roles of these things are closely associated with grammatical constructions in a sentence. These are sometimes called the terms of the Aristotle's sentences. Now, when we come to the Stoic construction of logic, the emphasis is a little bit different. They're interested in statements of a generally broader kind. So they're interested in statements that involve propositions, P and Q, which are themselves independent little statements. And they're interested in relating propositions or combining them. So, for example, if P and Q are propositions, then they might be interested in this implication. If P, then Q. For example, maybe P is, it is raining, and Q is, I get wet. So those are standalone sentences. It is raining, I get wet. And this statement here is a composite that combines these two propositions. If it is raining, then I get wet. It's an implication. So we might say that that sounds like a reasonable implication. If it's raining, then I get wet. Yes, that's a true implication. Another way of combining things is to form a conjunction using this logical connective and instead of if then. So both P and Q. Both it is raining and I get wet. It's another way of combining these two ingredients to form a larger idea. And then the third one, a disjunction, involves the term or, the logical connective or, either P or Q. Either it is raining or I get wet. Now, we have to flag this one here because this one is quite different from the modern usage. Okay? The Stoics interpreted this sentence in an exclusive or fashion. That means they were considering such a statement to be true if one of the two possibilities was correct, but not both of them. So typically, these two would be two different sides of a coin, or sort of like opposites, or mutually exclusive kind of possibilities. For example, night or day. Either it is night or it is day. Okay, it's not going to be both night and day. Either this way or this way. Either we're going left or right. Either you're a Democrat or you're a Republican. Either it's hot or it's cold. You know, that kind of binary division. That's the kind of thing that's represented by their use of this logical connective or. Today, in what's called the propositional logic, we are more embracing in this interpretation. So we interpret the or in a broader sense. So we're able to say red or flat. Either something is red or flat. And then that'll be true if it's either red or flat. So it could be red and not flat, could be flat and not red, or it could be both red and flat. So they were interested in logic as describing statements that are formed like this with these kinds of logical connectives between propositions. So it was really an early propositional logic, actually something that got going again 2 millennia later in the 19th and then 20th centuries. And the Stoic logicians identified what they called 5 indemonstrable forms. So these are basic kinds of arguments that could be used, a lot like the Aristotle syllogism. So the same kind of thing. We start with some premises and then we're able to derive a conclusion. But the nature of the statements are different. They're involving these connectives. So there's 5 of them. Here they are. And the first one is here along this first line. So let me explain how to read this. So there's actually 3 statements here separated by these 2 colons. So the first statement is, if P, then Q. Statement number 1. Statement number 2 is P. And the conclusion is, therefore, Q. So we read this in the following way, that we'll suppose this is true. We'll suppose that it's true that if P, then Q. And P and Q are just names for some propositions that we've identified, but it doesn't really matter what they are. So we're assuming if P, then Q. And we're also assuming P. So in other words, we're assuming if P, then Q is true. We're assuming that P is true. It follows then, if you put these two together, that we can deduce the truth of Q. So we say, therefore, Q. So if you know that if it is raining, I get wet, and you know that it is raining, then you may deduce that I get wet. That's a legitimate form of argument that they actually called, well, they didn't call it, probably later medieval people called it modus ponens. So this is the Latin name for this type of argument. Now a variant of this is the following: if P, then Q, not Q, therefore not P. For example, if it rains, then I get wet. We know that. Not Q. I do not get wet. So what can you deduce from those two things? If it rains, I get wet, and I do not get wet. You can deduce that it is not raining. Not P. And that argument's called modus tollens. Okay, here's another one. It's got two things as well. So the first one is not P and Q. So here's another kind of connective to take the negation of a statement. That's what the not is doing. So it's not true that P and Q. And P, including not Q. So if it's not true that I'm going to town and I'm having dinner, if it's not true that I'm doing both of those things, that's what this means, both of those things, and if it's not true, and you know that I'm going to town, then you conclude that I'm not having dinner, because I've said that it's not true that I'm doing both of those things. I'm doing one of them, so I must not be doing the other. Okay, here's another one involving the disjunction or. Now remember that their disjunction is different from ours. This is an exclusive or that they're talking about. It's important here because this is a difference from our usage. So their rule is that if you know either P or Q and you know P, then you may deduce not Q. If it's day or night and it's day, then you may deduce that it's not night. This is not a proper or valid argument in modern logic. It's not. So this shows that logic has a point of view. It's not as if God has given us logic. Logic is something that humans create, and we say, okay, this rule makes sense in our context, and someone else says, oh, this rule makes sense in this context, and other person says something different. Okay, so that's an important thing to appreciate here. And the final one, another disjunction, either P or Q. Not P, therefore Q. I mean, that one's more familiar. So the Stoics were in possession of these 5 forms of argument, and they called them indemonstrable forms. And I guess that means that to them, these were like obviously true. You can't demonstrate them because they're just true. A little bit like Euclid would have said, well, it's true that between any 2 points you can draw a line. Euclid could not prove that. So he just had to say, well, that's obviously true. We're going to assume that as a basic fact. So something like that is going on here. And it's an interesting question, actually, about, from a foundational point of view, whether these facts, if they are indeed facts, are things that we're assuming or things that we are confident are true. or things that are maybe capable of being demonstrated. Like if you're teaching these things to young people, do you just say, hey guys, just memorize these? Or do you say, look, these are true statements, and because of the following reasons, and you give some reasons, you give some explanations, you try to pin them up, you try to buttress them somehow. Okay. In any case, we see that they're not far from actually quite modern approach to some basic propositional logic of even taught in universities these days. Now, quite a fascinating aspect of their thought is that, remember that we don't have a lot of complete writings from these people, so we're not really in possession of their own writings on things. But nevertheless, we do know that this so-called law of excluded middle was something that they thought about. And this is actually a famous conundrum that even plays a big role in 20th century logic. There's still points of view. Different people have different points of view as to the validity of this logical tenet. So what is it? It's actually quite simple. It's concerning a statement involving a single proposition P and its negation, not P. So if you look at the combined sentence, P or not P, P or not P, and you ask, is this statement P or not P necessarily true? Is it necessarily true that P or not P? So let's say the statement is it is raining. Then this statement would be, it is raining or it is not raining. So in that case, most of us would say, okay, that's kind of obvious. But the answer to this question, is this statement necessarily true, is actually that it depends on who you ask. There are differences of opinion as to whether this is a valid, true statement. So to give you a sense of that from a modern point of view, suppose I ask the following. Suppose that P is it raining or not, but suppose that I ask, the statement P is, the universe is infinite. Okay? So the universe is infinite or the universe is not infinite. Is that a true statement? Well, it's not so clear now, because to decide whether the universe is infinite, whatever that means, or to decide that the universe is not infinite, whatever that means, might very well be beyond our capabilities. It might be that accessing those truths individually is just something that we're incapable of. And so then I think one could at least forward the argument that then we're not in a position to understand the meaning of the conjunction of two statements. If we cannot understand the validity of two individual statements, then we probably should not be making statements about the conjunction. And there's some sort of seeming reason for that, although you could also argue the other way, and people do argue in lots of different ways. Now, Aristotle addressed this kind of issue in a famous sort of thought experiment, where the proposition P was, a sea battle will take place tomorrow. Maybe the Persians are parked out there in the harbor, and we're wondering, will a battle take place tomorrow? So P is the proposition, a sea battle will take place tomorrow. And not P is then the proposition, a sea battle will not take place tomorrow. Okay, so now the question is, the combined statement, P or not P, is that statement true today? Today, is it true that a sea battle will take place tomorrow, or it's not true that a sea battle will take place tomorrow? Well, this is kind of a philosophical thing, and it touches base with aspects of determinism and, whether we're in a position to how we think about the way the world unfolds, because we're talking about the relative position between here and tomorrow, and making statements about tomorrow and today. So Aristotle is often seen as coming down on the side of the answer here is yes, but I think actually modern scholarship is a little bit divided on what Aristotle actually thought about this. In any case, the Stoics also were, let's say, skeptical about whether this thing here was necessarily true. Now, Stoicism was something of a fatalistic philosophy. They kind of had this idea that, things are the way they are, and your job is to just accept things and, and keep a happy proposition as best you can. So they certainly lean towards determinism. Maybe they accept a limited amount of free will sort of around the edges. That's sort of relevant to this question and this question of P or not P. And let me try to explain that here in terms of what might be called a truth table. Now, I don't think the Stoics had such a thing, but this kind of thing will play a bigger role as we get into the 19th and 20th century versions of logic. So, and this is also something that the Stoics would have understood very, very clearly, I think. So let's say we have two statements, P and Q, and these are the various possibilities for them being true and false. T being true, of course, and F being false. So these are the four possible combinations. And this records the possible truth values of the composite statement P or Q. So if P is true and Q is true, then P or Q is actually false. We could put an asterisk there because in our version this would be true, okay? But in the Stoic interpretation of this, that's false. If one of them is true and the other one is false, then the disjunction is true, and similarly in this case that's also true. And if they're both false, then this thing is false. So maybe the Stoic would have said, okay, so in order to determine what's going on with this one, what you need to do is you need to see which row of the table you're on, okay? You identify which row of the table you're on. P is false, Q is true, and then you look over, and then you can determine that P or Q is true. Fair enough. Now, if we go back to the sea battle question, here's P, here's not P. So they're related in a very simple way. If P is true, then not P is false. If P is false, then not P is true. And now we can ask, okay, so suppose we apply this thinking. What about P or not P? Well, what we have to do is we have to look on the relevant thing over here and sort of see over here where we are. And so either we're here or we're here. In either case, we would get a T, but maybe we're not actually sure which one of these it's likely to be. So maybe there's some kind of question as to whether we're really allowed to draw the conclusion that P or not P is true. So I guess we come back to this question of what exactly are we doing here? How are we determining the truth of these various things? Are we just stating that things are true because it makes sense to us, or do we have some underlying methodology or proof system to kind of support our statements? You see, there's some foundational issues here which are sort of underlying this question. There's another interesting point at which we think that the Stoics had a different approach to things than we do, and that's having to do with the temporal aspect of truth. So when we're looking at simple examples, there's a kind of a stationary aspect in time, like the dog is sick, the dog is not sick. But actually, if you actually have a real dog, the dog might be sick today, but next week it's not going to be sick. So things change over time. And so there's a question about what happens to the truth content of a statement if it's inherently dependent on time. So for example, the statement, "It is warm today." Maybe the statement is true. Actually, here today in Sydney, it is a warm day, even though it's the middle of winter. So the statement is true. I can say it is warm today, and that is a true statement, at least for me today. But a question is, will this statement retain its truth forever? For example, in 6 months, can we look back at Norman then and say, Norman said a true statement. So if we look back at Norman's statement 6 months from now, and maybe it's cold outside, is it then still a true statement? Or the fact that the conditions have changed makes the statement, "It is warm today," no longer true? So I think the modern approach is to somehow regard statements as somehow time indexed, if one might use that terminology, meaning that we're kind of associating a statement with a given time. And so even if we look at that statement years to come, we can see the index when it was made. And so we can say, yes, at that time it was a true statement. So therefore it is still a true statement, even though it doesn't really apply to us now. But the Stoics did not adopt this position. Okay? So they had this idea that a given statement can change its truth value over time as the circumstances change. So that brings up a whole kettle of fish, which is quite interesting. It actually comes to play an important role, I think, in later developments of logic. How the truth or otherwise of statements depends on time. And so we can see the origins of that already in the Stoic opposition to the way we regard things. Now, the implication is a very interesting logical connective, the form if P then Q. And it often causes students of logic some problems, even in the modern classroom. And this is the modern formulation of how to interpret this statement. And in fact, it turns out that it's the same one that the Stoics had. So the Stoics had the same perception or understanding of the implication and its meaning. So let's look at this. So here's P, the various possible values for P and Q, all four possibilities. And here's this composite statement, if P then Q. So if P is true and Q is true, then the statement if P then Q is also true. If P is true and Q is false, then the statement if P then Q is false. In fact, that's the only time it is false. If P is false and Q is either true or false, it doesn't matter, then the implication is true. So this causes students some problem because then we have statements like this, which are, according to this, true statements. So I'm going to take a blatantly false statement, like let's say, if Norman is 30 feet tall, okay, that's obviously not true. And then I'm going to put here some maybe a false statement. Then 2 equals 3, okay? So now the following is a true statement. If Norman is 30 feet tall, then 2 equals 3. That is a true statement according to the modern rules of logic and also according to the Stoic rules of logic. Yeah, that's interesting. And so it's interesting to point out that the Stoics had this understanding of implication. And well, we'll talk more about this when we get to 19th century work and the work of Boole and so on. Now, I'd also like to mention this alternate school, the Megarian school of philosophy, that sort of was somewhat parallel to the Stoics, and they influenced each other. So this was founded by Euclidius of Megara, not to be confused with Euclid, who was a student also of Socrates, actually. So it's a rather early school. And then there were followers Ichthyas and Stilpo around the 4th century BC, and they definitely influenced the Stoics. And so again, we don't know too much about their philosophy. Not too much that's written down, that's comprehensive, is available, but we have indirect understanding. But we know there was another fellow called Diodorus, and it's interesting that he had the following position, that he was interested in what is possible. What does it mean for something to be possible? And he said that what is possible is actually limited to what is or will be true in the future. So this is very different from the way we think about things. So if we go back to the sea battle, okay, there's going to be a sea battle tomorrow, or maybe there's not going to be a sea battle tomorrow. We don't know. But we think, one of those things is going to happen. So according to him, from where we are now, if we say, the statement, both of these are possible, it's not really true. It's not really true that both of them are possible. The one that is possible is the one that's actually going to happen. So if there is actually a sea battle tomorrow, then today we are correct in saying it is possible that there is a sea battle tomorrow. If tomorrow there's no sea battle, then it's not correct for us to say, well, there's possibly going to be a sea battle tomorrow. So, again, maybe this connects with determinism, with the idea of the universe flowing along some set way. Anyway, I find it interesting. It's very counterintuitive for us, but maybe it's not entirely unreasonable. Another question, I guess, that's behind all of these things is, what is the nature of truth? Going back to Plato and probably earlier people. And although I said I'm going to be rather objective since this is my last slide here, let me step back from my objectivity and just give you my own 2 cents worth here. I think that a lot of this discussion, while it's quite useful and interesting, and turns out to be particularly useful when we come to the 19th century and 20th century logic, but for different reasons, which we'll come to later. Okay, so there's different reasons why this is quite important. But in terms of just a calculus of propositions and whether they're true or false, I think it's very simplistic to think that the world is organized that way. I mean, in reality, there aren't that many statements which are entirely true or entirely false. Yes, most statements are kind of more or less true or more or less false, but there's also quite a lot of statements that are in some kind of gray area in between. And as you get older, you, I think, get more experience with the idea that, it's really hard to say on which side of the fence, if there is a fence, there probably isn't a fence, various situations are. And it really often depends very much on your position and your history and your makeup and where you're coming from, the culture and so on and so forth. So absolute notions of true and false somehow to me ring as simplistic, and this is some kind of baby version of the world. It's not really representative of what's really happening in the world. And I have the sense of, with all these examples, Socrates is a man, all men are mortal, therefore Socrates is mortal. This is some kind of like toy example that's only minimally directly useful to the modern world. I can't see anybody winning a political debate by bringing up, this incredible insight that if Socrates is a man, then, blah, blah. No, I don't think it's going to happen. I think debates and arguments are usually won by much more subtle things, for other reasons, not by appealing to some kind of syllogistic logic like this. Now, I'm not saying that they don't have some use, but I'm saying as a comprehensive guide to truth in the universe, I think this is a very modest kind of undertaking. Okay, so that's my own position. That's not to minimize its interest and its importance, but it is the case that over time, the Stoic, the Megarian way, actually did pass into decline. So it was more or less forgotten as the years went by. Aristotle's logic became the logic, and in the medieval period, which we'll talk about next time, it was really all Aristotle. And only actually relatively recently, in the last 100 years, has there sort of been a resurgence of interest in the Stoic way of thinking and an appreciation for how close they were in some regards to modern logic. So that's quite interesting. So in our next video, we're going to go further into the medieval period and see how logic progressed on its way towards the 19th century, where things changed very dramatically. So I hope you'll join me for that. I'm Norman Wildberger. Thanks for listening.